Hello friends, hello dear students, how are you? Good evening to all. Today we are going to cover on continuation of switchgear and protection equipment regarding to diploma 5th semester Fine Art 4 A, the switchgear and protection subject, unit 2, circuit breakers and reactors. In that previous class we have discussed some how arc can be quenched, how arc is formed by using the different high resistance method and low resistance methods. At the same time, we have seen a different type of switchgear and protective equipments generally used in our power system at various stages, at various places also. Today we are going to further interesting and easy equipment, that is oil circuit breaker. Before going to that subject, let us introduce myself. My name is C.H. Yadaya, Senior Lecturer in Electrical and Electronics Engineering, Government Polytechnic, Usnabad. Let us see. Now we are going to learn today. This is a circuit breakers. As you know, if you are seeing the left side circuit breaker, that oil circuit breaker, which is generally used 2-3 decades ago. Now latest we are using right side circuit breakers. You can see what is the size of these breakers. Before 3 decades and now what is the size? By technology evolution, the compactness of the circuit breaker, the effectiveness of working properties increased. Let us see what is the process of circuit breakers from old system to new system by different stages. In our syllabus, we are going to study from oil circuit breakers to latest gas, sulfur hexafluoride SF gas, different type of circuit breakers. Now, so what are the today objectives? On completion of this topic, you would be able to know the introduction to oil circuit breakers, basic principles of operation of bulk oil circuit breaker, construction of bulk oil circuit breaker, arc quenching mechanism in bulk oil circuit breakers, and merits and demerits of bulk oil circuit breakers. These are the few things regarding to oil circuit breakers. First of all, we should know what are the oil can help to quench the arc. What is the necessary? First of all, this arc quenching purpose. So let us see, before going to this oil circuit breakers, let us recollect what we have seen previous classes, some few things at a glance. Now the definition of switchgear already we have seen. What is that one? The operators used for the switching and controlling and protecting of an electrical equipment is known as switchgear. Any equipment that can help to switching purpose. After switching, we require to control. After controlling purpose, at the same time that should be protected. These 3 main functions should be required for a switchgear and protective equipment. At the same time, overall protection also very overall maintenance also required. This is the definition of switchgears. What are the switch? So if you are seeing the switchgear equipment in your domestic home, it is a switch, simple switch, lighting switch, less than 5 ampere switch in our houses. If the load is increased, protective switch. What is the protective? Here a different type of the fuses, from rewirable fuses to the carriage features, HRC features, glass fuses, different type of the fuses for the different applications. Now for going to the our distribution system and power system, where we are going to operate the higher voltages and high rate of current also, then we are going to operate those equipments with intelligence equipment. That intelligent equipment is nothing but the relay. Here you can see the circuit breaker. With help of the relay we can operate the high level, high grade currents and voltages. The simple, the switchgear equipments already you know. Not only this one, you can see what is this one. It is a MCB isolators generally used in domestic. The switches, the air brake switches, oil brake switches, knife switches and isolators, generally already we have seen these all things. Now protective equipments, KitKat fuses and rewirable fuses and carriage fuses. Now this is a circuit breaker, and circuit breakers are maybe different types of the circuit breakers already we classified based on its based on the voltage, based on the media used, based on the whether it is outdoor or indoor, different factors already we have seen. And now last one is the relays, intelligent equipments. The just like is a Buchholz relay you have observed in our transformers, and overcurrent relays, over voltage relays, differential relays and impedance relays, different type of the relays also. These are the family members of switchgear and protective equipments. Each member has its own the characteristics, own importance to protect our distribution system and to maintain a quality power to our consumers. Now for example, you can see the simple circuit what you have seen. This simple circuit generally used in our domestic. It has a source, it has a load, it has a switch to control. If anything happen, we require some big boss, that is the fuse, protective equipment. Here under normal condition without any problem, then whatever, if your switch closed, the current closes, the current will flow in a closed circuit. If anything happen in a circuit, then automatically it will protected from the high current from source. Otherwise the total circuit may be burn out. So how it will takes place? How the circuit burn? What is the impact? How the arc will comes? If arc comes, what will happen? If anything problem to us? So electrical arc is a very dangerous as comparing to the normal fire, which is a wood fire and a diesel fire and a kerosene fire. But those can be quenched by using the different medias. If possible, we can require water also can use it to quench the fires. But whereas in our electrical fires, arcs, flames cannot be nullified by using the water. We require the special purpose of materials. What is the intensity? How this arc takes place in our day-to-day life in distribution and power system. Let us, you can see at a glance what is the intensity of these short circuits occurring in our distribution system. We know that electrical energy is a very good slave. At the same time, if you are not used properly, it can act as a boss. It acts as a destroy the everything. So we have to careful every time while using the electricity. Even we are following so many rules and regulations by providing the good insulation. Sometimes there is a possible to leakage current. There is a possible to unwanted accidents. Due to this one, total fire hazards. Fire hazards and the equipment fails, operators may be fatal death. You can see what is the intensity of these fires, how these short circuits are going on. Even we are going to maintenance taking place frequently. You can see before that one, you can see a simple circuit where even domestic having the less than 5 amperes for the lighting load, even if the fault occurs, how the arc is coming, you can see it. So when the circuit is closed, the current is passing, the load is whatever the energy taken from the source is giving the light energy. Now I wantedly created the one short circuit in a circuit. Now you can see I placed one ground short, then automatically the power is stopped. There is no current flowing coming from the source. The fuse is blown. You can see that is the arc. You are observing this arc. So this arc is a very high temperature, nearly the 5000 degree kelvins. That much of the temperature. The temperature may be so fallen on any the materials, that may cotton or some gases, there is a fire accidents. So we don't want that the arc cannot be avoided, but arc will come. If arc comes, we have to very quickly quench that arc. That is our aim. Sometimes what will happen if there is no control, if you are not control that arc at instantly, if the fault current is flowing continuously, here whenever the fault occurred, automatically the fuse is blown, the current is switched off. But in domestic, in distribution, in power system, some unwanted accidents maybe takes place. At that time, the short circuit is continuous flows from few seconds or few minutes. During the flowing of the short circuit current, the problem of the flames arcs continuously maybe takes place. You can see one video, you can get some idea how this arc is coming real life. Now you can see the person is trying to cut the lines. So this the lines are, you want to cut the lines, but what is happening? So you don't know so whether the lines are live or dead, but you wanted to cut the lines with using the some cutting plier. Then what is happening? You can see here. So you are trying to cut in total R, Y, B 3 pieces. You can see what is his mistake. Line to line faults. You can see the domestic transformer fail, cable fail fault. Actually our circuit breaker should be tripped, otherwise what will our transformer is burning continuously. I think it is a DTR failing. In our substation, you can see the pole. On pole there is a small the leakage current. Now it is a short arc, fraction of seconds. Now here also nearby cable is fail. 11 kV maybe short circuit of the cable. Here you can see the simple service wire. Due to the small short circuit, what will happen? Next fault may be, if persist, it may be increased. You can see that is a dangerous. If fault sustained, it will go on increasing the fault severity. You can see it. Cables are burned out. Total collapsed. Now you can see the is opening the switch or closing the switch. Now you can see tripped. You can see it. In substation, so you can see the blasting of the PTR. You can see it. Lakhs of rupees. Now you can see the service wire. Two poles in between. There is a small short circuit. The continue along the line. Total is burning. The fault should be stopped immediately, otherwise problem. You can see the operator is intensely closing switch. Then what will happen? You can see it, just like it is a bomb, total collapsed. Simple mal-operation. Whatever the insulation, that may be melt. You can see what is the severity of electrical energy. Under normal condition, nothing will happen. If anything goes, you can see it. What is the severity? Due to the simply. It has to trip immediately, otherwise the fault severity is very, very high. Now you can see the intensity. Now you can see the another transformer failing. This is an arc. Simply arc is generated due to the short circuit current. Once the short circuit arc is persist for long time, it may blast. It may use surrounding material as a fuel to blast it. You can see here also what is happening. You can see this is the electrical energy, very dangerous. You have to be very careful. So we have to switch off the supply immediately at the substation. So these are the severity. You can see it. So you can see here also one thing. Normal distribution lines. Small arcing takes place. Now total system collapsed. Initially the fault current is very, very less. And now transformer burning in substation. Simple distribution system also. So while closing the switch, you can see it. In the transmission system, due to the loose contacts. So these are the different type of the reasons for the fault current. Now you have some idea what is the intensity of this our power, intensity of dangerous of our electrical energy. So if the fault as possible as we are going to clear it very quickly, the limit of the severity of the destroying our equipments may be protected. So this is a thing. So as an electrical student, you should know importance of the protective switchgear and protective equipments. Now let us see. So this is a substation where it has handling hundreds of amperes, thousands of volts. Everything should be as per IE rule. Otherwise, what will happen? If anything goes wrong, total system collapse. As you know, what is happening now. So, as we know that this, as a student, we should know how this switchgear and protective equipments is operating in our daily life, from generating station to our domestic, how the electrical energy is coming and how we are going to controlling this electrical energy at every stage by using different switchgear and equipments. At a glance, already you have seen this one, a single line diagram of a substation, that is energy coming from power station, for example NTPC Ramagundam to, so the power supply to our Warangal house. How this energy is transmitted to the nearby Warangal substation, that is the 220 kV substation Mulugu road. From that it is going to the 132 kV Veddapalli substation, step down to 33 kV, and 33 kV substation once again going to step down at REC Warangal substation, where is 33 kV by 11 kV feeder. From that 11 kV feeder is coming to the circuit house road, where we have the one distribution transformer. Then we are step down to the 400 volts 3 phase, 230 volts single phase. So in every stage we are going to using different switchgear and protective equipments, isolators, circuit breakers, and different type of the relays, protective equipments, jumpers, all things. So you can see one circuit diagram. Now this power is coming to the circuit breaker and is coming from the isolators, CTs and PTs and circuit breaker, and after closing the circuit breaker, next stage it is going to the bus bar and it is entering to the nearby another stage, where the circuit breaker once again it has to close. Now I close the circuit breaker, then it is coming to the PTR primary side. After whatever the rating of PTR, step down to required voltage, once again it is given to the group circuit breaker and secondary side, and that is given to the our nearby house. So this is that means from this station to this station, in every substation, every stage, we are going to use a different ratings of switchgears, different types of switchgears, different companies of switchgear. Also we are going to redundantly we are using every high voltage switchgears redundantly two at a parallel. If one fails, automatically other will take care of. That is the importance of switchgear and protective equipments in our substations. Now you can see, so method of arc quenching extinction. Now we have seen the what is the severity of the arc, how the arc is go on increasing if time passes. Now how we are going to nullify that one? As we know that, so last class we have seen arc can be quenched by high resistance method and low resistance method. And high resistance method, what we have done, so we are going to use the lengthening of the arc. Whenever the arc is coming, lengthened by lengthening the arc, cooling the arc, reducing the cross section of the arc, and splitting the arc, we are going to reduce the nullify the arc very quickly. This is the process in high resistance method. Already we have seen clearly in step by step with so many examples. But in case of the low resistance method, the low resistance method can be used for only AC supply. So that is the zero crossing method. So in AC we have the positive cycle, negative cycle, positive cycle, negative cycle, that is the 50 cycles per second in a Indian frequency. So whenever the current, whether it is the normal current or short circuit current, reaches to the zero crossing period, so at that condition we are going to open the breaker. So how to find? So we have the latest technology. We can easily find that zero crossing points. So whenever it coming to the either maybe short circuit current coming to the zero position, it will wait for few seconds, microseconds. At that it is going to relax for few microseconds. That time we are using to nullify the arc. That is can be done in case of low resistance method. How we are going to nullify the arc? Already we have seen by splitting, by blasting, different methods. So here there are the two ways to achieve this. So how we are going to, whatever the arc is developed, this from we have seen the outside in atmosphere, different places due to the small falls, the arc is occurred. Now we in our, while we are opening, closing our circuit, there is a fault is we are going to create. The fault arc is going to create whenever it is opening and closing and opening. At that condition, so if arc is comes, how we are going to nullify it? That is our aim. Now how we are going to nullify this arc? So here we have the different methods. You can see here. Now, so there are the two ways to achieve this, the causing. One, how we are going to nullify this arc. First one, the causing the ionized particles in the space between the contact to recombine into the neutral molecules. Whenever the arc is occurred between the male and female contacts, that ionized gas is a path to flow of this short circuit current. Then the continuous arc is coming. Now we have seen how the arc is continuously sustained for few seconds and minutes. So that can be avoided here also, if as long as being there a ionized path, gas particles, then current, the short circuit will try to flow. Once short circuit current flowing through the ionized path, there is a continuous arc is taking place. So what to do? So we have to remove their assistants. What are the assistants? Ionized media. That is the first thing. Next, so we have to recombine. Once the gas is ionized, what will happen? So under normal condition, the neutral molecules, the gas is having the high dielectric strength under normal condition without any arc. Once we are opened, the opening gap has, so whenever the short circuit occurred, as we know that whenever the short circuit occurred, the power factor of the system goes to nearly 0.1 lagging. At that condition, what will happen? The voltage increased enormously. The current is reduced. The voltage increased enormously, and current will reduce. Because previously, whenever the power factor is lagging 0.1, at that condition, current is more and more. That is the short circuit current. Once the arc is coming, so the gap is developed between these two, then what will happen? The voltage increases very high. Then current is reduced to the circuit is very less. So that means the arc duration directly proportional to sin alpha. Alpha is the phase angle between the voltage and power factor, that is the angle between the voltage and current. So that means that ionized particles, once that voltage, the high voltage, whatever the media between the two contacts is forcefully going to ionization takes place. The ionized particle is nothing but electrons and ions. So if these ions and electrons persist in the medium through which our short circuit current is trying to flow, so the arc is continuous. Here the short circuit current is try to flow through our arc. Arc is nothing but flexible media. Flexible means is ionized gas. If in the first case, if whatever the electrons, whatever the ions, if recombined into neutral molecule by some external method, then automatically there is no media for flowing of short circuit current. So arc may be automatically quenches. That is the first thing. Second one, the sweeping the ionized particles away and replace them by unionized particles. If otherwise, what will happen? Whatever their assistance presence on the way, so we have to remove that fellows with new unionized gas particles. That already we have seen in last class. Now you can see the one simple braking mechanism, how the arcing takes place in a line. Here, so already you know that there is a fixed contact and a moving contact. There is a load. The current is coming one direction. So you know whatever the current is coming, it is going in this direction under normal condition because circuit is closed here. This is a fixed contact, is a moving contact. The moving mechanism taken place by ear, whether you are going to do manually or remotely or automatically. Then what is happening? So if you are going under normal condition, what is the, if once the moving contacts are moved away, then there is a gap between the fixed and the moving contacts. The arc is coming and the arc has the 5000 degree kelvins, that temperature. So try to melt the tips of the metal parts. So what is happening here? So arc sustains some time. So instead of placing this moving and fixed contacts in open atmospheric condition, we are going to place in a closed vent. Then whatever the arc comes, that can be limited within the chamber. So that is the modern circuit breakers. So within the chamber, we are going to add some more media to quench arc very quickly. That may be oil, that may be exhaust gas, that may be puffing up air blast. So 20 to 30 kg for centimeters of pressure of air, high pressure air. So that can pop, so taken away the ionized particles. That can be seen later. Now, so next stage, now it is a male and female contact. It's a open area. So arc is coming. The arc has a temperature. The temperature, due to the temperature, the tips may be melted, become the carbonized. So next one, after closing this one, there is a gap. So continuous short circuit may be occur. It is a mal operation maybe takes place. So to avoid that one, so we are going to place the fixed and moving contacts in some chamber, limited chamber. You can see that is the another circuit diagram. Now the mechanical operation, the gear and lever mechanism by spring mechanism, hydraulic mechanism, pneumatic mechanism. So here, so we are going to use the electrical sensing device that can operate the gear and lever mechanism. So you can see that circuit also. Now this is the another intelligent electrical system, the breaker operating system. Here, so you can see this one. So automatic, whenever the abnormal conditions comes in a line, so that can be detected by our CTPT, and that will gives to the relays, where relay will analysis, and that will gives the signal to our trip mechanism, where it will close that trip contacts or closing contacts based on requirement. Now here is some animation how what is happening under normal condition. If the fault occurred some in a circuit, then how the mechanism will goes, you can see it. Here you can see it. This is a normal current is flowing from input to output through CT, PT, circuit breaker, load under normal condition. Now I am forcefully going to make one fault area. So at the fault I am going to do here. Then what is happening, you can observe. Once I am going to opening, so here I am going to open. Now here created the one fault at the fault. Then what is happening? Now battery current is closed, the current is passed, given the signal to the trip mechanism. Now trip mechanism open the two contacts. Once it is opened, what is happening? What you observed? There is a arc is developed. Have you observed that thing? Arc is developed. The arc is going to quench. The arc is quenched by different methods. High resistance method, low resistance method. In low resistance method, so by using the different media, now we are going to use in our substations. So this is the basic idea of mechanism. Now, so let us see, in this class we are going to see oil circuit breakers. Here to quench the arc, we are going to use the oil as a media to quench the arc. Why arc is coming? What is its impact? Already we have seen. Now to suppress the arc, we are going to use the oil. So we known as a oil circuit breakers. Now we can see the one figure. So you can see normally used in substations. How big size this each. This is a R phase, this is a Y phase, this is a B phase. Each phase has a this much of the tank. So as you know that this tank capacity is nearly 5,000 liters of transformer oil is required here. Here the 5,000 liters of oil is required as a insulating media, as a quenching media. Just like you can see the small, big size, small size house hut for each phase. Now this is used in olden days. Now this is all replaced by latest equipments. You can see this one. So here you can see it, this one, this one, this one. Three can be combined into a smart one, that is known as a latest breaker. You can see it. The very good capacity compared to this one. It can easily capable to control the arc. So these are the latest technology. So let us see how this olden days first helped us to nullify the arc. Now, so what is the requirement of the circuit breakers? The two circuit breakers required. What is required? So for smooth operation of any breaker, it should be the shortest time for operation. So whenever the fault occurred, it should be trip immediately. Otherwise, what is happened in media we have seen different while it is a service wire burning, while in a circuit breakers. So different places, what is happening if it is not cleared immediately? So the fault may be persist for a long time. Short circuit current is flowing continuously, then continuous arcing, continuous problem go on, cascading problem. So first characteristics is required, shortest time for operation is required for a breaker. Next, carry its rated current without any heating. Under normal condition, you should not heat any heat. And last one is the withstand for mechanical and electrical stress. As you see, when arc is coming, there is so much stresses developing, whether it is mechanical stresses, electrical stresses, different atmospheric conditions. At that condition, it has to withstand. That mechanical strength and electrical strength is required. These three characteristics should be required for a good breaker. So these are the things already you know. Now let us see this breaker. Now already once again, based on the media whether you are using, so these breakers, let us classification. So already we have seen the breakers are classified based on the location, based on the voltage, based on the medium, and based on the location indoor and outdoor, and based on the here also indoor and outdoor is less than 36 kVA. So we can say is the indoor, and above from 36 to below 63 kVA we can say the outdoor circuit breakers. That means the above 36 kVA capacity, 36 kV we are going to use the in substation yard, not inside the building. Now coming to the based on the voltage, as we know that low voltage, medium voltage, high voltage, extra high voltage and ultra high voltage already we have seen, where low voltage is less than 1 kV, medium voltage is 1 kV to less than 52 kV, and high voltage is less than 220 kV, and EHV station already was in less than 765 kV, and whereas the ultra high voltage is the 765 kV. So these are the some classification based on these factors, already you know that. Now coming to this one, the based on the medium. So whether you are going to use which type of the media to quench the arc, whether you are using the oil, whether you are using the vacuum, whether you are using the air blast, whether you are using the SF's gas. So based on the media this classified. So this is the ranges: less than 133 kV, less than 33 kV, less than 1, greater than 130 kV, and whereas the SF's gas is the latest gas, latest equipment generally used from 3.3 kV to maximum voltage in the Indian transmission voltage is the 765 kV. So these are the different of the breakers. From this one, today we are going to concentrate on this OCB, oil circuit breaker. So these are the breaker we are going to study. What is the OCB, oil circuit breaker. Oil circuit breaker is such a type of circuit breaker which used oil, nothing but just like is a transformer oil as a dielectric or a insulating media for arc extinction. Whenever the separation takes place, so in between the two electrodes, the media we are used here is the oil. This oil has a good the insulating property as well as the and cooling property also. So this can be studied in this class. Now, so what is the, you can see here. Now, what is the basic principle? When the fault occurs in the system, the contacts of the circuit breaker are open under the insulating oil. So, in the insulating oil, we are immersed two male and female contacts in a oil. When it's short circuit condition or faulty condition, when moving rod is withdrawn from the fixed contact, what is happening? It's a gap between the fixed and moving contacts, and the arc is developed between them, and the heat of the arc is evaporated in the surrounding oil. As we know that when arc comes, it has the arc as a 5000 degree kelvins, that much of the temperature. So whatever the surrounding touching to the arc, the oil is decomposes and becomes to the vapor, water vapor, and forms a bubbles. So it is a hydrogen bubbles. So not only it becomes the gas bubbles. So most often nearly hydrogen gases, methane gases, ethylene and acetylene, the different the properties. So majority of the hydrogen gases, so developed in the tank. Now what is happening? Which creates a turbulent pressure in the closed tank. Now what is happening? Under normal condition, whatever the some area occupied by this oil, now the oil becomes to bubbles. The bubbles having the high pressure hydrogen particles. Now it is the 1000 times the volume occupied by this each bubble. So that means pressure developed inside the chamber becomes the very high. That pressure is required to increase the dielectric strength of media which is between the two electrodes. So which leads to quench the arc. Now you can see now let us see the oil circuit breakers. The oil circuit breakers further classified into bulk oil circuit breaker and minimum oil circuit breakers. Now bulk oil circuit breakers where it has a 5000 liters of oil for quenching each phase, whereas in minimum oil circuit breaker or poor oil circuit breaker where 10% of oil used in bulk oil circuit breaker can be used. Only 10% of the 5000 liters of oil can managed here minimum oil circuit breakers. Whereas bulk oil circuit breaker, so we have used that much of the oil for cooling purpose and insulating purpose. Whereas this one minimum oil circuit breaker we are going to use only quenching purpose. That is only interrupting chamber we are using. And this oil, whereas a bulk oil circuit breaker, this oil can act as a insulating media from face to body. The body is grounded, the metallic body, earthed body. So we will see later what is the comparison between the bulk oil circuit breaker and minimum oil circuit breaker after completion of minimum oil circuit breaker. Now the bulk oil circuit breaker is further classified into the two types. One is a single break circuit breaker, other is a double break circuit breakers. Here the breaking means where you are going to opening, similar to the isolators. We have seen single break isolators, double break isolators. In single break isolators, only wherever the break takes place, the arc will comes. Double break isolators, the center it is a rotating, it is a two sides, it's a breaking takes place, the double break. Similarly, here also single break circuit breaker and double break circuit breaker generally used. What is that one? We can see later. Now you can see one bulk oil circuit breaker size. What is the size this circuit breaker at starting? You can see what is the size of each phase. Here you can observe this is a R phase, this is a Y phase, this is a B phase. So you can see how much oil is inside, and if required maintenance, how much oil we have to replace. That is the maintenance also very high. Now you can see the construction of oil circuit breakers. So let us see. You can see here, this is what is the construction of oil circuit breaker. Now, so it consists of current carrying contacts enclosed in a strong weather tight earth metal tank, and the tank is filled with transformer oil. Here you can see it. So this is the transformer tank, and this is the earth. This is the metal part. The oil is both acts as a arc quenching media as an insulation between the live parts and earth. Here, so what is happening? Whatever the oil inside, so it acts as this oil. This blue color is oil. It acts as a insulating media from the live wire to this earth. Earth is a neutral. So neutral phase is between this oil as a insulating media. Now quench, at the same time it is a cooling media also we are using. Now at the top of the oil you can see it is not filled, so some gap is provided, cushioning purpose. Air is filled in the tank which act as a cushion to control the displaced oil on the formation of gas around the arc whenever it is occurred. Now also observe the mechanical shock of the upward movement of oil whenever the fault takes place. We are not filled totally oil, so 1/3 portion is we have kept empty to occupy this vapor gases. And now you can see the breaker tank is securely bolted for carrying out the vibration caused by interrupting very high current, because already we have seen whenever the fault is occurring, sir, the mechanical stresses and electrical stresses is developed very high. At the same time, whenever the arc is struck between the fixed and moving contacts, so that arc is absorbed by the oil becomes the hydrogen bubbles having the very high pressure. That air is try to come out outside, but is the total is sealed. Then what is the pressure inside? So what is the turbulence inside? If it is loose, if it fitted without any tight arrangement, then it will go out. It should be come out from the platform. So to avoid that one, we are going to, it should be very tight position on a basement or cement concrete slab. So oil circuit breaker consists a gas outlet which is fitted in the tank cover for the removal of the gases. After, so we have the some vent also we have provided to go out the whatever the gases here after clearing that gases. So these are the something you have to know. So this is the construction. What is inside? You can see it is a metallic part. It is a tank. You can see it. So what is it? It has the metallic tank, and it is a here you can see that this is a moving rod mechanism. By outer mechanism we can lift it upper side, and this is the oil, dielectric oil. This is the fixed contact. So upper one is the fixed, this is the fixed contact. The double brake system here, this is the one braking, this is the one braking, double brake system. Now this is the bushings, input and output. For example, whatever the current under normal condition comes and enters, goes. But what is happening if I opened this contacts? Here the contact is opened, you can see it, there is some arc, red color arc is coming here, so that is the arc. So what is happening that arc? So arc is creating the problems. So that is nullified our aim. Now let us see what has happened. So what is the operation? Now working principle, we can see this is the constructional point of view. It has a conductor, it has a bushings, it has a fixed contact, it has a moving contact, it has a tank, it has a dielectric oil inside, and it has a 1/3 is empty for the cushioning purpose. So here this is the basic construction of each phase oil circuit breakers. This is the one phase. Similarly R phase, Y phase. Now let us see the working principle of oil circuit breaker. How it will works. What is the basic principle? So here you can see the one. Okay, let us see first. Now you can see it. The construction of the already we covered this whole thing, and it is a similar to this one. Now let us the working principle of circuit breaker. So here, so the braking mechanism of circuit breaker. Now what is happening? Already we have seen whenever the problem occurred. So under normal condition, whatever the current is coming here, it is going this direction. Now what is happening here? So during the normal operation conditions, the contact of the oil circuit breaker is closed and carry the current without any effect. It is going smoothly through the load. When I make the fault here, fault current. When a fault occurs in the system, the contacts of the breakers are moving apart. So as we have seen, moving contact and fixed contact. This is going this direction. This fixed one is going this direction. And the arc is struck between the contacts. There is an arc between the two structs. Now here is an arc is coming in between this one. Due to the arc, a large amount of the heat is liberated and a very high temperature is reached, nearly 5000 kelvins Celsius, which vaporize the surrounding oil into gas. So that gas consists of the majority of the chemicals, hydrogens, methane, ethylene and acetylene gases. The hydrogen gas cannot be remain in a molecular form, and it is broken into its atomic form by releasing a lot of heat. So it creates nearly arc temperature nearly 5000 degree kelvins. The mixture of gas occupies a volume about 1000 times that of oil decomposed. If the external pressure is applied on a bubbles, then the rate of deionization process of ionized gases medium, which leads to increase the dielectric strength of the media between the contacts. So this is going to happen by using this gas. The arc is, so once the pressure increases, whatever the ionized gases in between, a forceful becomes to the unionized particles. That means whatever the electrons, whatever the ions converted into the neutral molecules. Once it becomes the neutral molecules, then deionization takes place, then automatically the dielectric strength of increases, then whatever the voltage unable to ionize once again. The arc is extinguished due to this one. The arc is extinguished when the distance between the fixed and moving contacts reaches a certain critical value. We are going to critical value. Depend on the arc current and recovery voltage based on the voltage and rating capacity. So these are the things already you know. This is a braking mechanism in a circuit breakers. Already you have seen this circuit diagram. So these are the things already you know. Now what is happening? Already you have seen. The CT you can see here. So under normal condition, what is happening? Under normal condition, whatever the, you can see normal current is flowing. At that condition, here CT ratio, for example, it may be 100:1:1. That means whenever this rated is the, for example, 100 amperes, the current flowing in the CT secondary is a 1 ampere. The 1 ampere is flowing through the trip coil and it producing the flux. That flux unable to pull this trip contacts upper side under normal condition. So the trip contacts are opened. Due to this one, our battery is not in pictured, so no supply to the solenoid coil of this mechanism, that no operation under normal condition. If fault occurred, what is happening? Now I am going to create the fault here. So now what is happening? Fault is created. Now battery current is closed. In this case, what is happening? Now in this current, whenever the fault occurred, the current may not be 100 amperes, the current may be 1000 amperes, for example, 10 times. Instead of 1 amperes, the current may be 10 amperes flows in the secondary. Now previous case, unable to pull the trip contact upper side. Now due to the 10 amperes, the flux produces more and try to move this plunger towards this one. Due to this one, the circuit is closed. Once circuit is closed, battery comes into picture. Whatever the battery current is supplied to the supply energy to the solenoid, our mechanism, then mechanism is operated. Now you can see it. It is our contacts are opened. Once circuit is opened, already inside the oil, so that is a high dielectric strength through which this electrons will not flow. Then total system is collapsed. That means here whatever the fault current is stopped immediately whenever the fault occurred by sensing our CT and PT by giving the signal from the relay. So it is opened, no short circuit current coming from the 100 ms. So whatever the arc is nullified immediately, no problem to the here. Previous case we have seen the videos. What is happening is a continuous fault current is flowing and making the nonsense. Now here by using our breaker, so it is stopped immediately. This is the thing you should know. Now coming to the working principle of circuit breakers. Now we have seen the basic principle. Now how this operation takes place, you can see. Similarly, so you can see here each is circuit diagram is here. It has a one limb. This is another limb. So whatever the current is coming here, it is going. Now it is coming and it is going. Represented. Now let us see. So how it is working. And clearly by drawing figure. Now what is happening here? So here we can see, so male and female, this is a fixed rod. You can see this is a fixed rod, is a moving rod. In between there is a white color is the arc developed when it is a arc. Now in this case what is happening? The fixed rod and moving rod is both are closed condition. Now previously no fault current, no arc takes place. Now this yellow color is a dielectric oil, total yellow color only. The oil vapor, there is no bubbles. Now there is no arc. During the normal operation conditions, the contact of the oil circuit breaker is closed and carry the normal current. Whatever the current is coming are simply flowing, no arc, no problems. When the fault occurred in the system, the contacts of the breaker are moving apart and the arc is struck between the contacts. Now the problem occurred. Now it is this is mode, this direction, moving contact is a mode from this one. So what is happening? Here dotted is the arc is developed. So due to this arc, a large amount of heat is liberated and a very high temperature is reached, which vaporizes the surrounding oil into gas. So it becomes now gas. Now after that what happened? The gas thus liberated surrounds the arc and its explosive growth around it displays the oil velocity. Whatever the gases having the turbulent pressure, so whatever the oil nearby contacts are replaced by these bubbles and gas particles with high velocity. The arc is what is happening due to the high pressure, ionized particles converted into unionized particles, which are the enemies to the current. Then what is happening? whenever the pressure increases, ionized particles entered, the resistance increases. The short circuit current may not flow through it. So the arc is extinguished when the distance between the fixed and moving contacts reaches a certain critical value, a defined value. Depends on the arc, its rating and capacity. So these are the things you have to know. Already we have seen this is the working principle of oil circuit breaker. Now you can see. So these are the simple, easy. So but same you have to know what is happened inside this thing. Now operation, same thing we have seen. So when the separation of the contacts has just started, a distance between the current, already we have seen all things. Now what is happening here? You can see it's arc temperature may reaches the 5000 degree kelvins. Due to the high temperature, the gas is liberated surrounding the, so already we have seen gases, everything is we have covered. Now you can see the one figure it. So how this is the HV terminal incoming and HV terminal outgoing, how the operating rod between, that is the moving contacts. Here is a double brake system, here the braking here and here, and so here is the R control devices and latest we are going to providing. You can see that is the how the fixed rod and moving rod takes place in this device. You can see the side figure, one figure. This is the one figure. So where the fixed rod is this one and the moving rod this one. So initially this rod is here. Now once it is withdrawn from the fixed rod by this mechanical force downwards, then what will happen? Here is the arc is taking place. Due to the arc, so these all are filled with the oil. So what happened? Already you know. You can see the clearly with this figure. Here you can see this is the one rod. The here single brake. You can see the single brake. Previously we have seen the double brake. A single brake. What is happening here? So in single brake, so whatever the current is coming here fixed rod and moving rod coming here is going on. The oil is filled, empty places, and this mechanism operation, everything is over. Whatever the current is coming and going. Now this can be under normal condition. So when the separation of the contact, so when separation is not taking place, what are the simply current? Once separation takes place, what is happening now? This rod and here, this rod and this rod and this rod is separated by mechanism. What is happening? Now we can see automatically the arc will come into picture. This rod, this rod. Now what is when separation of the contacts has just started, the distance between the current contacts is small. As a result, that the voltage gradient between the contacts become very, very high. That voltage easily ionizes the media between the two contacts. This high voltage gradient between the contacts ionizes the oil and consequently initiate the arcing between the contacts. The arc will produce a large amount of heat in surrounding oil and vaporize the oil and decomposes oil in mostly hydrogen and a small amount of methane, ethylene and acetylene. Already we have seen. The hydrogen gas cannot remain in molecular form and it's broken into its atomic form, releasing a lot of heat. That heat is we are going to using here. So this is the operation of single brake system. So you can see the figure how this is taking place, all things. Now we can see it. Now coming to it is classified into the single brake and double brake system. Single brake and double brake, already we have seen what is the basic principle, what is the construction, everything. Now so based on this one, how once again we can recollect. It is a single brake system. So what is a single brake system? Here single only breaking the, you can see previously this is a single break, where breaking the only this place only. So in single break bulk oil circuit breaker, there is one pair of current carrying contacts. You can see the figure also. You can see here. So in single break oil circuit breaker, there is a one pair of current carrying contacts for each phase of power system, power circuit. The each pair of the current carrying contacts is in the bulk oil circuit breaker consists of one fixed contact and one moving contact. Fixed contact is stationary contact and moving contact is moves away from fixed contact during opening of the circuit breaker. As the moving contact is moved away from the fixed contacts, the arc is produced in between the contacts and it is extinguished during zero crossing of the fault current. So fault current is very high, but it has to come at normal zero crossing period. At that condition, at that time it has to take some rest. During that rest we are going to open our breakers, and during the period we are going to increase the unionized media in between the contacts. Then arc will quench, arc may not be continue for the next cycle. So that is the thing. Here you can see the same single break. What is happening here? The arcing part is generally the axial float. So we can see so how the pressure is developed. Whatever the arc is coming here, that arc is coming here, that is pressure full. The pressure is applied here, so arc will come here. So by this we are going to nullify the arc very quickly. So this is a single break system. Similarly, double break system also you can see it. This is the double break system, already you have seen. Here also it has a two arcs taking place, left and right, and here is the so mechanism also provided, a mobile mechanism. Here we provide the cross jets through which arc, whatever the arc is coming, that pushed this through the shooters. During the, what is happening, once it's moving away, so lengthen the arc. Once arc is lengthened, then automatically cools. Once it cools, the dielectric strength increases. So this is the main aim of circuit breaker. Now this is the bulk oil circuit breaker construction, basic principle, its operation, single break and double break system. I think you have the enough idea about this oil break system. Now what are the advantages of this circuit breakers? Now let us see. The oil has a high dielectric strength and provide the insulation between the contact after the arc has been extinguished. So after extinguishing the arc, oil is present inside. It acts as a dielectric media. So it is avoid restriking of the arc once again. Second one, the oil used in the oil circuit breaker provides a small clearance between the conductor and earth and conductors. Here the face to face are two conductors in between. So we have the dielectric media act as a oil as a dielectric media, at the same time conducting, and metal body is a dielectric media. You can see this one. And last one is that the hydrogen gas is formed in the tank, which has a high diffusion rate and a good cooling properties. These are the three advantages of oil circuit breakers. What are the disadvantages? No. So it has some disadvantages. What is that one? The oil used in the oil circuit breaker is inflammable. Now we have seen what is happening. The transformers are blasting due to the oil. Inflammable, and the cause of fire hazards. There is a risk of formation of explosive mixture with air if it contacts. And due to the decomposition of the oil in the arc, the carbon particles is generated which polluted the oil, and hence the dielectric strength of the oil also decreases. These are the three disadvantages of oil circuit breakers. So these are the things already you know. What are the advantages? It has a high dielectric strength. It acts as a insulating media from live part to the body part, and it has a hydrogen gas. It acts as a good cooling property. Now what is the disadvantages? So what is the, it is a inflammable and risk of explosion, and at the same time carbonization of oil, a continuous more number of process, the carbon formation takes place, then dielectric strength of the oil decreases. So we have to filter frequently this one. These are the few things we have seen here. Now I think so you can see the few more, you can see it testing, how the circuit breaker is testing. So this is the size of circuit breaker.
Important and critical component of the power delivery system.
The operating system, you can see.
Switching devices capable of making, carrying, and breaking current in normal and abnormal conditions. During abnormal conditions, such as when lightning strikes a transmission tower, circuit breakers isolate the faulty components of the system to prevent additional damage. Ideally, in the closed position, a circuit breaker should act
how
as
the
a
moving
perfect
rod and fixed rod is
conductor
moving
to ensure optimal current flow.
inside the
open
circuit breaker.
position, an ideal breaker should act as a perfect insulator and should be able to break the current instantaneously. Circuit breakers feature fixed and moving contacts that are housed in an arcing chamber and are opened or closed by an
The
operating
blue color is
mechanism.
the arcing chamber,
The
red one
breaker's
is the
operating
rods.
mechanism controls the moving contact to quickly open or close the
You
circuit.
can see the
When the
mechanisms.
contacts open, an arc is created due to current interruption. An AC arc extinguishes at every zero current level, but reignites immediately after crossing the 0 point due to the presence of voltage across the open contact. In order to avoid arc reignition, the contacts must be separated with sufficient speed, and the dielectric strength across the open contacts must be able to withstand the transit voltage. Circuit breakers commonly feature an arcing chamber where the arc is intensively cooled by insulating media. Breakers are classified based on the insulating media used for arc suppression. The main four breaker types are air blast, oil, vacuum, and sulfur hexafluoride, SF6. This timeline shows the popularity of each breaker type over the years.
So
Most breakers
1922,
today are either
you can see the
vacuum
beyond
or
this one.
SF6 breakers due to their smaller size.
Before that one, oil, we are using the
Substation
oil
breakers
also,
are
water also.
classified as either independent pole or tripole. They are further
So each
classified
phase
as
are
live tank or
gang
dead
operation.
tank breakers.
Live tank
Independent
and
pole
bend
breakers
you can see
feature
here.
a separate operating
In
mechanism
each
for
phase,
each phase,
separate.
while tripole breakers
So
use
three
a common
phases the
operating
common
mechanism for all three
gang
phases.
operation.
Live tank breakers use a switching device in which the vessel housing the interrupter is at a potential above ground.
You can see the high
Dead tank
voltage.
breakers use a switching device in which a vessel at ground potential surrounds and contains the interrupter and the insulating media. Regardless of the type, it is very important to test circuit breakers regularly. Regular testing can ascertain proper breaker operation in case of system fault and can improve system reliability. Various tests can be performed to evaluate the different components of a circuit breaker. Contact timing tests are used to compare the breaker's main and resistor contact performance against the manufacturer's specifications. The breaker's open, close, close, open, and close, open operations are timed in milliseconds and cycles and compared with the manufacturer's specifications to determine the performance of the breaker. Motion tests performed with a transducer are used to check the mechanism's stroke, velocity, damping, and over travel against the manufacturer's specifications. Slower speeds can reduce the braking capacity of the main contacts, while faster speeds may cause mechanical damage to the damping components and cause excessive vibration. A breaker's control circuit can also be tested by measuring the trip and closed coil current and the minimum pickup voltage. The measured values are then compared with the manufacturer's specifications to ensure optimal performance. The operating coil's current waveform provides insight into the mechanical and electrical condition of the operating coils. Any significant changes from the benchmark test signature should be further investigated. Contact wear is also another important factor that can affect a breaker's performance. A dynamic resistance test can be performed, and the resistance chart can be used to analyze the breaker's contact condition during the circuit breaker operation. In order to maintain optimum breaker performance, the various tests described here should be routinely performed. Vanguard Instruments offers a wide range of circuit breaker analyzers that can help make routine testing safe, convenient, and cost-effective. Please visit our website for further information.
So these are the things you have to now. So let us conclude our session today. So what is that one? Now let us conclude our session. What we have studied today, class? So summarized. So introduction to oil circuit breaker and basic principles of operation of bulk oil circuit breaker, construction of bulk oil circuit breaker, an arc quenching mechanism of bulk oil circuit breakers and merits and demerits of bulk oil circuit breakers we have seen. In addition to what is the intensity of arc, how it may be occurred day to day life, we have seen one video. At the same time, so how the breaker is importance in our electrical field, how it can be tested, and what are the its generation, how the breakers are developed from water as a media to SF6 gas media, and we have seen the another video. I think you have the what is the bulk oil circuit breaker, what is the important breaker, so we have some idea. So this is a thing. So next class we are going to the minimum oil circuit breaker. So thank you very much for listening my class. Thank you. అయిపోయినాయి. అరే ఇప్పుడు క్లాస్ ఎదురా వీడియో అయిపోయింది, దాన్ని అప్లోడ్ చేసుకోవాలి కదా. ఎందుకు దా అయిపోయింది, అది అయిపోయింది, అక్కడ పెట్టుకో. సరే
మధ్యాహ్నం మా ఫోన్లు మా అమ్మనైతే ఇంకా మధ్య తెస్తుంటే రోజు పడుతుంటే ఊరుకుంది.
సాత్ ఇది అప్లోడ్ ఇది మన కనిపించట్లా. మరి ఇప్పుడు క్లాస్ అవుతారా?
సేవ్ చేయలే.
సేవ్ ఎందుకు ఆటోమేటిక్ అదే అవుతుంది కదా.
సేవ్ చేయాలి.
సేవ్ లేదు, ఏం లేదురా. అవసరం ఒక్క నిమిషం. సేవ్ అవసరం లేదు, రోజు సేవ్ చేయాలి. ఇక్కడి నుంచి వస్తుంది కదా దాని నుంచి.